term punctuated evolution is part of the new extended synthesis language. How does it differ from the Eldredge-Gould concept of punctuated equilibrium, which argues that evolution has not been a gradual process as reflected in the fossil record?
Yeah, so this is it's a somewhat controversial area because it involves, first of all, estimations of time scales. When Gould and Eldredge first presented their idea of punctuated equilibrium, they were just pointing to the fossil record and saying that things that were considered gaps in the fossil record because there were discontinuities in the forms that were uncovered might not truly be gaps. Things may have happened relatively fast, and therefore one form supplanted another form by evolutionary processes that were not entirely gradual. Okay. Now, then there was a kind of, over the years, I would say, kind of a backing off from considering what evolutionary biologists would call saltational mechanisms, which are true jumps, so that you have one form being replaced by another form very rapidly. Gould and Eldredge would both talk about rapid in a geological sense. So they were talking about millions of years of evolution rather than hundreds of millions of years of evolution. I actually, from our own work and the work of other scientists looking at physical determination of biological form, there's a very good case to be made, and there's a lot of experimental data behind it, that true jumps are possible. So I'll give you an example of, we now know that the mechanism by which the number of segments of organisms like ourselves are generated, like our backbones have serially repeated vertebrae. So there's a certain number of them, 30, 40, and some snakes have 300. Okay, and we know that the process that generates these blocks of tissue is a process that involves an oscillation, a clock-like mechanism, and this kind of beats time, and the time is translated into spatial discontinuity. So whenever you reach a certain point on the clock, you cut off another block of tissue, and you do it again. And that clock can run faster, or the clock can run slower, and what makes the clock run fast or slow, even that if it is a small change, it can lead to a transition from 40 blocks of tissue to 300 blocks of tissue, all in one step. So you can get saltational jumps. Doesn't have to be gradual. You don't have to go from 40 to 41 to 42 to 43 up to 300. You can get jumps like that, and we know that that's the case. So even though Gould and Eldredge backed off of saltational mechanisms, we now know from embryology that saltational mechanisms are very plausible mechanisms of evolutionary change.
You say that all 35 or so animal phyla self-organized by the time of the Cambrian explosion 500 million years ago using a pattern language, dynamical patterning modules, DPMs, and that selection followed as a stabilizer. Is that correct?
Yes, that's what we...
As these terms apply to your hypothesis, what do you mean by self-organization and selection? Do you mean selection in the Darwinian survival of the fittest sense?
Yes, to some extent, and there are other ways that selection acts as well. So, first of all, the self-organization, we mean that when cells get together and form clusters, there are physical processes that are relevant to material on that scale. So a single cell is a very small object, and it's subject to certain physical forces, and cells can be knocked around randomly if they're in a fluid medium or something. when you get to larger structures, you have things operating like diffusion, the flowing of materials from one end to the other that can cause non-uniform gradients. And you have cells and clusters, some of them being more strongly adhesive and some less strongly adhesive, so you'll get a separation like two immiscible liquids like oil and water, so that you get different layers of tissue due to this process. Then you can have interactions between cells where a cell will exert some inhibitory effect on the cell next to it. So cells right next to one cell won't do the same thing that that cell is doing. So these are all processes that use molecules and genetic means that were evolved for single cells, but in the new multicellular context, along with the physical processes that are characteristic of this kind of more larger scale matter, you get organizational principles kicking in that just weren't there in the single cell state. Cells have these clocks inside them, these oscillations, and in the single cell world, an oscillation just periodically changes the state of a cell, but in the multicellular state, the oscillation can lead to spatial segmentation. So you have, you're mobilizing things that existed before, that evolved in the single cell world, but then when they meet up with the physics of called mesoscale, middle scale materials, you get all these morphogenetic processes, these form-producing processes that come into play. So to give an example, a molecule of water doesn't have waves and it doesn't have whirlpools. It's just a molecule and it has the physics of molecules. When you have a lot of molecules of water, they make liquid water, and then you can get all sorts of disturbances and wave-like and vortex-like phenomena, which you would never see in the individual molecule. It's not that the molecules have changed, but the scale has changed. So new physics comes in and organizes the system.
So the selection that you're referring to, though, is not Darwinian.
Well, yes. So let me
survival of the fittest.
So let me go on from there. Yes. So as I said, the forms that you get are not due to Darwinian selection. They're due to the inherent properties of the system. But many of those forms may not be viable. That you might get forms due to physical organization that just are not suited to this world. They just can't find a place to live. They can't eat or whatever. So there'll be a shakeout phenomena. Some of them will survive and others won't. So in that sense, the Darwinian mechanism of selection is a kind of culling process. It doesn't create the forms, but it basically determines which ones of them will persist in the world. So there is a role to this Darwinian selection, but it's not a role of building up forms in an incremental fashion, or at least by and large it isn't. It's culling these self-organized forms and just selecting among them.
As these terms apply to your hypothesis, what do you mean by sort of self-organization you've described, but
you had brought in self-assembly and the distinction between...
Many scientists say the terms self-organization and self-assembly are interchangeable. Some say the snowflake forms by self-organization. You call the snowflake formation process self-assembly. Some scientists describe the self-assembly of the hydra, for instance. You did extensive experiments with the hydra in the early 1970s in England. at the University of Sussex. And you term the hydrous regenerating process.